Example 1.2 Coulomb's law. 3-point charges lie along the x-axis as shown in figure 1.2. A. Calculate the magnitude and direction of the total electrostatic force on Q1. Part A, write down information. Q1 is 12 microcoulomb. Q2 is negative 20 microcoulomb. And then Q3 is 36 microcoulomb. And you have here is a distance between Q1 and Q2 is R12. Okay, label here R12. And then distance between Q1 and Q3 is R13. R12 is 12 cm. Negative 2 here. And then R13 is 12 plus 20 cm, 32 cm. And then now sketch the forces acting on Q1. So on Q1, it is a positive charge here. So positive charge Q1. And then Q1 and Q2 has an attractive force because they are positive and negative charges. Then sketch F. Here label is F21. And then for charge Q1 and Q3, both are positive charges, and on Q1 it has a repulsive force. So repulsive force here F31. Now calculate F21 and F31. So F21 is KQ2 Q1 over R12 squared. K is 9 times 10 power of 9. Q2 is of course 20 times 10 power of negative 6. No need write down the negative. And then 12 and times 10 power of negative 6 divide by 12 times 10 power of negative 2 squared. So your F21 is 150 Newton. Your F21. How about your F31? F31 is KQ3 Q1 over R13 squared. And then F31 is a substitute value. Q3 is 36 times 10 power of negative 6. Q1 is 12. And then your R13 is 32 times 10 power of negative 2. Sorry. Meters, right? F31 is 38 Newton. Okay, next step is you want to find the total electrostatic force. So you can find the magnitude. How do you find the magnitude? Because F21 and F31 is opposite, both are opposite direction, then your magnitude for F1 is F21 minus F31, because F21 to the right, F31 to the left. So F1 is 150 minus 38. F1 is 112 Newton. And how about the direction? because you get positive here, meaning that the direction is direction to the right. Or you can write as towards Q2. Example 1.2, Coulomb's law. For part B, suppose the charge Q2 can be moved left or right along the line connecting the charges Q1 and Q3. Determine the distance from Q3 and also the where Q2 experiences a net electrostatic force of 0. B, you have here is Q1 12 times 10 power of negative 6 Coulomb. Q2 is 20 times 10 power of negative 6 Coulomb. And then Q3 is 36 times 10 power of negative 6 Coulomb. And here, as we can draw here, the charges positive for Q1, and then Q2, and then Q3 is positive. Okay, determine the forces on Q2. Now, for Q2 and Q3, it will be attractive force. Label is F32. And then for Q2 and Q1 also attractive force. So you can label is F12. And then don't forget to label the distance. Distance between Q1 and Q3 is R13. And then distance between Q2 and Q3 is X. Distance between Q1 and Q2 is R13 minus X, of course. Okay, because the net force acting on Q2 is 0. Okay, I write down here is 0. Then means that F32 minus F12 is equal to 0. Means that F12 is equal to F32. So, here Q1 Q2 over R12 squared, and then Q2 Q3 over R23 squared. Then substitute value, where you actually can cancel K here, and also you can cancel Q2, of course. So here you have 12 times 10 power of negative 6 over R12 is actually between Q1 and Q2, which is 32 times 10 power of negative 2 minus X squared. And then Q3 is 36 over X squared. Okay, then when you calculate it, you will get X is 0.203 meters.